So I'm Adam Stueckrath. The project that I did was a machine learning project to identify Syrian Civil War comments and sentiments. So just a brief overview of the Syrian Civil War. It is a conflict of the government versus the people, a religious war, and increasingly a proxy war between Russia, Iran, and the United States. Over 500,000 people have been killed, and it's displaced half the country's population. It's currently the largest humanitarian crisis in the world, and on the right is a map of areas controlled by different groups in Syria. And as you can see, it's quite divided and a very complicated situation. So I wanted a topic that is constantly developing, uses social media, and is relevant today, and the Syrian Civil War came to mind. I've been following the unrest and protests in the Middle East since 2011, and what's happening in Syria. It is the most covered and documented war in history, and there's a lot of data. So a Pew Research study said that Syrians and people in the Middle East are 2 to 4 times more likely to share religious views and politics online, and this is important because it represents a major paradigm shift in the way that modern conflicts play out. In the US, people generally use social media purposes for talking with friends or entertainment, but in Syria, it's taken on a much more serious approach, such as sharing information about what's happening in their communities. Like I said, it is the first civil war in history due to which social media has been used so extensively. So the first thing that I did was set out to get data. I didn't know what question I was going to answer, or I was trying to answer, but I knew I wanted to do a data science project, and the first thing that you need is data. So I went online and I started researching for sources. Here are the data sources that I ended up using. Through research, I actually ended up connecting with an individual in Finland named Daniel. He had previously done research on the war, and he provided me with a Twitter data dump of about 3 million tweets. The next data set that I ended up using was the Carter Center's project on Syria. They collect information about dates, violence, location, and fatalities across Syria. And I initially requested access to their data, and they said yes. You can see on the left-hand side. However, they never responded to me after that, and so I ended up using their publicly available data, which was about 3,000 events for my project. So I needed to narrow down the goal. I started getting my data, and the first thing that I did was I manually selected an event, and I started searching for tweets that were similar to that event. You can see an example on the right-hand side where I grabbed an event text, the tweet text, and saw that they were similar. And from there, I developed my questions. Such as, can I classify tweets to specific events? The tools that I used for the project was Python. I have some experience in Python, but I didn't have any experience in machine learning libraries such as NLTK and sklearn. Visualizations, I use Matplotlib, Seaborn, and Folium. So the framework. My solution uses unsupervised learning implemented by Tf-Idf vectors, cosine similarity, and various methods for validation. The first thing that I did was pre-processing. So I needed to structure my data. My data came in, was very messy. So I reduced noise with natural language toolkit. And from there, I started working on my algorithms. So Tf-Idf is known as term frequency inverse document frequency. It is a common method to identify important documents based on how important the words are, where word importance is determined by rarity. It produces a set of order numbers or a mathematical representation of my data as a vector. You can see an example on the bottom where I have a tweet and an event, and I produce a vector of each. And from my 2 vectors, I'm going to calculate the cosine, or how similar they are to each other. So it is a measure of the cosine of an angle between 2 vectors, which is the tweet between the event. It generates a metric to say how related the 2 texts are. the higher the score, the more likely they are to be similar. So overall, I found 40% of my tweets were similar to an event. And that was what I did, set out to do, was to match tweets to events that they were about. Of those 40%, there were 12% likely that they were a high probability of a match to an event. You can see an example at the bottom screen where there's a good match and a bad match. I like the bad match example. It's pretty funny. But some of the validation methods that I use, since it is unsupervised learning, it is difficult to validate. I think the very easiest thing to do is just eyeball and to manually check labels that have been classified. Next is k-means clustering and calculating the silhouette coefficient. So future work, just community detection, understanding the sentiment around different groups that I've calculated. And then finally, thank you. It has been a great pleasure to be a part of this fantastic program. I want to thank my mentor, Zach, ChiPy, and everyone who's helped me in my research. Thank you for your time, effort, and the pizza.